Hi, this is Kate from the Royal Astronomical Society here at the National Astronomy Meeting 2019, and I've just grabbed one of our presenters straight from his presentation, Alexander Lozinski from the British Antarctic Survey, University of Cambridge. Tell us a bit about the work you've just presented.
Sure. So we've been looking at the radiation damage due to radiation belt protons that affects satellites being launched into geostationary orbit. But in particular, we're looking at satellites launched using all-electrical propulsion systems.
And so how would that differ from the usual launch conditions and getting them into the right place?
Sure. So electric orbit raising, as it's called, when you launch your satellite using all-electric propulsion systems, is kind of a new technology commercially. Even though electric propulsion has been around for a long time, the way satellites were previously launched to geo or geostationary orbit is using a chemical propulsion, and this takes kind of a few days to raise your satellite from what's called the geostationary transfer orbit all the way up to geostationary orbit.
So the rocket will take you up to put you in a geotransfer orbit, and then we're talking about the kind of propulsion that gets you from the geotransfer to the geostationary orbit.
Yeah, exactly. And the key difference is with this new electrical propulsion system that the raising from your transfer orbit may actually take up to 200 days because thrust from these new propulsion systems is a lot lower.
So if it's taking so much longer, because it would just be a couple of days with a chemical propulsion, why would you do it?
Well, there are significant mass savings, and the effect that has is a much reduced launch cost when you launch a satellite using electric propulsion. And this is really important because it can actually allow, first of all, it may allow the business case to close on a satellite. And secondly, you are now able to stack satellites inside the same launch vehicle. So potentially has a big impact on the commercial missions to GEO.
So 2 for the price of 1 in your rocket, basically.
Yeah, maybe.
But your research was showing that this, increased time to get to geostationary orbit can actually cause some damage. So, I mean, how significant is this?
Well, what our research shows is that in a worst case scenario, the radiation damage that occurs to your satellite during electric orbit raising can be quite significant, maybe equivalent to quite a few years spent in geostationary orbit. But the message from our research is that there are certain ways to mitigate against this type of damage, for example, by choosing your transfer orbit cleverly and choosing the appropriate level of shielding for your satellite solar cells.
Okay, so if you're a commercial satellite provider and you want to know how to save your satellites while using electric propulsion, we suggest you head on over to the Royal Astronomical Society website. And if you're not at the conference and want to join in with what's going on, check out the hashtag NAM2019 on Twitter and other social media.